Hey everyone, we'll get started in just a moment. I'm just making sure everything is fully set up because, well, YouTube's being weird. That's all I have to say. So, let me just switch over to our little intro scene and then we'll get on our way. So, we left off in the last video, which I did ages ago, I realize, setting up our camera pawn and the custom movement controller. So, the thing we have where we can move our character around or our pawn around is actually controlled by our test player controller here, where we just put some things in to test it around, or test around with the pawn. One thing I like about doing the edits or doing videos is I can edit them. Live streaming I can't edit as much, so you'll have me misspeaking every so often. I apologize for that. Alright, so we have all of this stuff, and well, for doing this in C++, we don't want to have all of this here. Now, all of these bits here, all the nodes we're calling from our camera pawn or our custom component come from our C++. So what we're doing in this video is actually creating these events. And the first thing we need to do, I'm not sure why that webcam came on with that, even though the webcam isn't turned on. Sorry about that, I just saw that it was there. The first thing we need to do is actually set up our inputs. Now, we already kind of have them. We already do have them set up. The information's right here clearly. But if you don't, what you want to do is you want to go to Settings, Project Settings, and when this pops up, you want to go into Inputs, which I can never seem to find easily, even though I know it's under Engine. And we have these commands. We have our pan right, our pan camera left, our zoom in, our zoom out, our reset zoom, something to make the camera move faster, our speed modifier, which is our left shift, our pan reset, which really should have been up there, but I just didn't think about when I did it. And well, I'm probably going to change this one, so we'll worry about the pan a little bit. But we also need our move forward and our move right. Remember, move forward covers forwards and backwards, where W will be our 1, so that's forward, and S will be -1 on that scale, so it'll move backwards. Same with our move right. D will be 1, which moves it right. A will be -1, which moves it left. So all we're doing is we're just messing with the scale there. So let's just pop open our test game mode, because actually no, we're not going to worry about our test game mode because we're going to not use it at all in this. So if we open up our C++ code from last time, we have our camera pawn set up with all of our functions. Here's our header file for that. And we also, of course, have the camera movement component, which has all the encapsulated information about controlling our camera's movements and the functions related to it. I'm going to collapse this back down because I like having these collapse when I'm scrolling through things. So what we need to do first to get our player controller set up is, well, create a player controller. So all we're going to do for that is go into our classes file, and just because it's easier instead of hunting it down, we'll go into our public, our core, I didn't mean to click there, and into our player. And we're going to create a new C++ class, and this will be of type player controller. And I'm just going to name this our RTS Player Controller. And we're going to create our class. And this might take a moment. And again, another thing I like about being able to edit videos for upload is the fact that I can actually cut this stuff out. So yeah, we're going to sit here for a moment, unfortunately, while it finishes loading, which gives me a good moment to take a sip of a drink. Sorry for the background noise, by the way, if there's any. I have my window open because it is boiling here. Alright, that took ages. I'm sorry about that. There we go. So we now have our header file and our class file, which, as you can see, are both completely empty. Now, usually we'll be starting in our header file, But today we're actually going to start in our class file. And the reason we're going to start in our class file is we're going to want to work on our constructors. Which I'm actually surprised it didn't give me a constructor. Just want to make sure it is the player controller I selected. It is. Okay. Fun. That's fine. So we don't have our default constructor, but we're going to just quickly set that up. If you're not familiar with what a constructor is in C++, and you're watching this as a video on demand, I do really recommend going and looking up C++ constructors. Just be aware that UE4 has a default constructor. Yes, there are ways to override it. No, we are not going to go into that in this video. So I'm actually going to cheat. I'm going to actually go in here and make sure we have a constructor set up in our header file. Alright, so we have our class, we have our generated body, but we don't have our constructor, so we're actually going to create our constructor first in our header. So we're going to do public, and then I'm just going to make a comment that this is our constructor, and all the constructor is the name of the class file, so a RTS Player Controller in this case, and our arguments, which are empty, and a semicolon, not an actual colon. So this is our constructor. I'm not sure why it's giving. There we go. So if we go back into here, we can actually populate our constructor real quick. And all that is I'm going to copy and paste the name in again. Use double colons. So we're saying the namespace is the ARTS Player Controller. And the function we're looking for is, well, the constructor. And we're going to have a couple of defaults we want to put in here right away. And we're going to want to do primary. I'm going to move that up, and I'm going to see what convention I used in the last one. If I put things on the same line or the line below it. Line below it. When I was talking about a convention, I mean where I put that curly bracket. Alright, so we're going to do primary actor tick. So this is for the actor, this is the tick function. And what we want to do is we want to say it can tick. So there's a function here, so we're using the dot operator to get to that function called, or not function, a variable we're going to set, and it's a Boolean variable. And like good old-fashioned C++, Epic has used B to start our Boolean. And we're going to do can ever tick. And you see the autocomplete already has that in there. And I'm going to set this to true because we want our player controller to be able to tick. We're going to use things on the tick in our player controller, actually. And the other thing I want to do is not only do I want to say, can this tick, I want to say that I want it to be able to tick at the start. So again, we're going to call our primary actor tick, and then we're going to look for another Boolean variable called b start with tick enabled. And we're going to set this to true. I still like having the spaces in there. So we are setting this pawn to call tick every frame. And we can turn off as needed. And if you're familiar with the blueprint version of the class files for this, you actually can change this in blueprint as well. So if I pop open this file real quick and just go over to our class file here, and we go over to our class defaults, we have start with tick enabled. So that's what this is. So we've just said we can tick, and we want that checkbox that I showed you to also be set. So that is our constructor. I'm just going to save everything real quick with Control Shift S. And then we are going to take care of some things as well. Now, we have a begin play event. And begin play, fortunately, should be in the parent class. So we should just be able to call and override that in our header. Actually, I don't think it is. We need to actually call that function up here. So I lied. We actually had to put it in our header first. And that will be a protected. And this will be our begin play. So again, if you're familiar with the begin play node in Blueprint, it's the same idea here, except for, you know, these events in Blueprints are really just functions. So this is virtual void begin play. And you can't change the name on this one because we're actually overriding a function in the parent class. Please tell me I spelled virtual right. Okay, I did. And you're going to get this little warning saying, you know, hey, you haven't defined this. That's fine. We're going to define it in a second. Now, what we want to call up in our begin plays, we want to make a few references, and we want to make sure we can see the mouse cursor. Now, if we're controlling the camera, then we're going to want to reference the camera pawn. We also, therefore, need a reference to the movement controller. Now, technically, you could get this through the camera pawn, but I just find it's easier to do it through the, to have a separate reference for it. So, I'm going to create another public section. Sorry, I just hit the wrong key. And in this public section, we're going to have our attributes and our method. So I'm just going to create two comments here real quick. One will be method. So these are our functions, and attributes. These are our variables. And we're going to have two in here in this video. I might end up putting two more in later on. I haven't quite, sorry, I clicked the wrong button. I haven't quite decided how I want to tackle some of the other elements of this. But, we'll work that out later on. And the other elements I'm considering about putting in here and not creating a blueprint class from this is our widgets, which we'll create in a couple of videos. But first, we're going to need our camera pawn and our movement controller. Now, before we can call these up, we actually need to have references to them. So we're going to do a new header, and we're going to do include, and then we're going to search for our camera pawn, which I'm just going to double check that is the name I use. I could just look at the top of my screen. It's camera pawn RTS is what I called it. You can see the name up there, but if you're not sure what the name is, just find the original source file for it. So we're in public for this one. What is in private? Okay. So sorry about that. So there is our camera pawn RTS. That's one we need to call up. So we're just calling this file up, this header, inside of here. I skipped the A in camera. That's why I can't find it. There we go. I am suddenly worried I've spelled something else wrong there. Oh, no, there it goes. Okay, so we need our camera pawn. And I think that's actually all we need. So we're going to use the camera pawn to get the header for the custom movement component. Sorry, I was blanking on some words there, it seemed. So now that we have that, actually, I'm just going to double check what I've said, because I suddenly have a lurking suspicion that I am not accurate in what I just said. No, that is actually how we're going to do it. Joys of having my notes in the other window. So we're going to do a U property. And you can actually skip the U properties. This isn't needed. And actually, to be useful, I'm going to go down the line before I continue. And I'll explain why in a minute. I've gone down the line. And we're going to name this as a transient property that we can edit anywhere. And that is blueprint read write. And yeah, I spelled U property correctly. And we're going to create a pointer to our camera class. So I'm just going to go over to our RTS camera here, and I'm going to grab the name there just to make sure it's spelled correctly, and it's a camera pawn RTS in my case. And since it's a pointer, we need our little asterisk or star there, and I'm going to name this variable our camera pawn ref. Please stop doing that. And now the reason I've gone down a line is, well, if I ever do decide to expose this to blueprints, I can fill in the tooltip right here. I can do a comment if I type in the right keys and type in, sorry, this is a reference to the camera pawn. Go down a couple lines again, and I'll set that comment section up again. We're going to do another U property. In fact, it's going to be the same U property, so I'm just going to copy this line. And it will be our U. Actually, I'm going to go back to the component. It's going to be our camera component. And I'm going to grab the name here. So it's the U camera component. Again, we're creating a pointer to this. And this will be our camera movement ref. There we go. And again, I'm going to fill this comment in. This is a reference to the camera movement component. If I spelled that wrong, I am so sorry. Alright, so now that I have these in, let's actually fill these references in. So, just because we've declared them doesn't mean there's anything in there. These are empty. If we try to use these, we'll get read nones, and actually we'll get a crash, but that's a different story. So let's go back to our class file. And in our class file, now that we have our begin play and those declarations, we can call up our begin play. So let's begin play, and we'll do void. Remember to skip the virtual when you do it as the actual definition. And again, we're going to use this ARTS namespace, and it will be begin play. And in here, because we are overriding the begin play that comes with the engine, we want to do a super, so that's what we're using for the override, begin play. Now we're going to do our reference cast at this point. And so let's start with our camera pawn. So our camera pawn ref. I gotta remember not to skip that A. I'm now really paranoid I just skipped the A in this one too. No, I didn't. However, paranoid me is just gonna copy the name to be on the safe side. Better safe than sorry. And all we're gonna do is we're going to cast to the class, which is a camera pawn. Actually, wait. Now I'm double check. A camera pawn RTS. Sorry, my note have a different class name there. So we cast to this class, and we want to find the pawn. So we're gonna do get pawn, and because this is single player, there's only one pawn to worry about. This gets the camera pawn. There's more details into how this function works. But we're casting to the class, we're saying what we want it to do. We want it to get the pawn, and it's going to return a value of whatever pawn we currently have, and it'll fill this reference in, or this variable in, so that we can use this variable. Now we have the camera movement controller, and I'm going to be a bit cheeky here and just again copy that, so I'm using the right name. And we're going to use our camera pawn reference to get the movement component. So we're going to take our camera pawn reference, and we are going to go from there to our movement component by getting our pawn movement component. And I'm actually going to double check that that name is right. So the way I'm going to double check that is I'm going to go into my camera pawn here, and I'm going to find the, actually I'm going to go into, it's going to be in here. It's going to be in our attributes and methods. Or sorry, it's going to be in our attributes. So these are methods, not attributes. Wait, no, that's an attribute. That's an attribute. That's an attribute. That's a method. Oh wait, no, that's an attribute. Sorry, it's not. Sorry, it's not reset default. I misread that. Where have I named it in here? Pawn movement component. And I just went back to the wrong file. Yeah, pawn movement component, so that's the right name. I just pasted it in anyway to be on the safe side, because I'm paranoid like that. Alright, so I'm pausing this real quick to answer a question. Hello, are you planning to drag the camera when the mouse button is pressed? And what do you recommend for weak relation between C++ classes for UE4? Alright, to answer the first question, I'm going to be using the WADS keys for basic movement. We also will be doing the edge scroll. So when you move your mouse to the edge of the screen, or to the bottom of the screen or sides, it will move the camera around. And as for your second question, and what can you recommend for weak relation between C++ classes for UE4? Oh, so for a weak relation, I would use interfaces. I mean, so people say casting is bad, right? And the reason why I'm casting here is because these things should never really. Actually, hang on. I'm thinking of a different program I'm working on. I would recommend interfaces typically. Now, I'm casting here because in Blueprints, when you cast, it does create a hard copy of it. Here, it doesn't have to load everything up until it's in-game. But due to the nature of an RTS, you're often going to be having these things on screen at the time you're running, so if you're casting or doing an interface, you're going to get the same sort of weighting, at least with C++. Now, if you're doing this purely in Blueprint, I know in my Blueprint videos I do cast, but I would recommend using interfaces just because they are slightly better for this sort of stuff. Alright, so now that we have our begin play done, we have our two references, we need to show the mouse cursor. And again, within this class, within the parent class of parent controller. So if we were to go into our game framework player controller.header here, or .h file, you can see a whole bunch of methods and attributes. There's one attribute that we want to use, and we're going to use this to show mouse. And you've probably seen this node in Blueprint. In fact, I know I've used it in the RTS Blueprint series, so if you follow that series, you have definitely seen it. And it's a Boolean variable that we can set, and that is b show mouse cursor. And we're going to set this to true. And if you don't know what I'm talking about in terms of Blueprint, I'm just going to pop open the file here, and I'm just going to type in show mouse cursor. That's actually the getter, show mouse cursor. It's this function, it's this node right here we're actually setting. So again, you can see that sort of one-to-one translation. It isn't a perfect one-to-one translation, but you know, you can see where the Blueprint material is coming from. Okay, so we have our begin play done. And if we move on from our begin play, well, we need to set up some other things, like our tick. You know, we've said we want a tick, so we need to actually set up a tick function. Now, I'm just going to quickly populate the tick function, and I'm not going to do anything with it until towards the end of this video, but it is like having this towards the top. So we have virtual void, and this will be tick, and we need to pass in an argument, and that's a float, and it's called delta time, with a capital T on time. And again, because this is something we're overriding, we'll just use override. I'm going to go back to the C++ file real quick. Actually, just want to make sure that, there we go. And in here, we're going to go into create a new function, and this function will be our tick function. And all we're going to do is make sure we're typing on the right screen and type in RTS Player Controller. I'm going to cheat again, and I'm going to do that. And 2 colons, tick, once again, float delta time. And all we're going to do is just get the super override in place. So we're going to do super, tick, and then delta time. We'll come back and finish this one out in a little bit, but I just want to have the tick right there. It's, you know, when you come into the Blueprint and you have begin play, tick, and there's always, typically, not always, but sometimes a third node or a third input, third event, sorry, it's an event. It's really a function, but in Blueprint, it's an event. I just like having that sort of same setup in my C++ files. Really, as long as this is at the top, the rest can be in any order. I just think this reads better and is easier to work with. So, now that we've done that, well, we need to actually start doing some things that make this a useful player controller. So if we go over to our class file, or our Blueprint file here, you know, we've done this. We're not using the UI. But now what we need to do is our input axis move forward and our input axis move right. We need to do our speed modifier, our zoom in, zoom out, all this other lovely stuff in here. And the way we're going to do that is, well, first we need to declare functions for them. Now, if you followed the earlier video, you're probably going, well, we already have functions to do these. And in fact, if you look at that file I just had up on the screen, which I just clicked the wrong button to put back up on screen, these are the things we worked on. These are the functions we wrote in the last video. Okay, that should just popped open the correct thing. I'm not sure why it didn't. So if we go over here, we have our, you know, where is it? Our basic movement controls. We have our pan. So we have to actually create functions that call these up. Now, if you're new to C++ and UE4, you might be confused as to why we need to do that. Unfortunately, player controllers only will recognize the functions for input events be it a bind access or a bind action event, if there's a function for it in the actual header and class file. So we could actually have created all those functions in here and have called them in here, which is actually what I did in the blueprint video, but it's technically not good form, so yeah, let's avoid doing that. Alright, so what we're going to do is we're going to create a whole bunch of functions, and the first one we need to do is actually we need to tell the system that it can use a player controller to get input. So we need to create an override, or sorry, a function for that, not an override. So it's virtual void setup input component. And we have no argument going into this one. Again, sorry for the background noise. So if we pop back over to our class file, all we're going to do is we're going to do a void. Again, I'm going to just copy to save myself a little bit of typo chance there. Our namespace setup input component. And with that in place, just put our curly brackets in. Why are you giving me an error? I'm paranoid I typed something wrong in here. I did. That should be a lowercase u, not an uppercase u. There we go. Okay, I went through. And again, this is something we actually technically are overriding. We just don't put override on it. So we need to do another super. And we need to call the set input function up again. And I just copied the entire line. There we go. And a semicolon at the end without the quotes I accidentally put in. So this gives us the ability to start doing input. Now, what we need the system to do for us is to get the gameplay key binding. So we're going to set up gameplay key bindings. And we have something called check input component. And so all we're doing is we're checking the input component. I just want to make sure I have skipped something very, very, very important, which is why we're getting that error. There's a header I'm missing. So if we go back into our file here, we have our, oh, sorry, no, actually it's in our class file here. What we need is we need our input component header. And so that is include components, and then it's input component.h. And this does go in your class file. Just want to make sure we also don't put it in our header file. No, we do not need it for our header file. Sorry, I just want to double check my notes on that. And we should, that error should eventually go away. Paranoid that it hasn't, but I would also, if you're, why hasn't that gone away? Actually, that's wrong. Sorry about that. That is the right header. I just put it in the wrong spot. It should be underneath the player control. It should be under the header for the class file itself. I also am going to come in here, and I am going to take this framework, and I'm just going to add that in. Don't worry about having it in two files. Within all the headers is the program once, or the pragma once, which will prevent it from being linked multiple times. It will just go, all right, here's all the code in the linker, and only do it once. So we have our controller header file, our player controller header, our input component, and I know we're going to need one more, but we'll take care of that one later. So now that we have our check done, we need to actually put in the events. So I'm going to just pop back over to our file here. I'm going to close this out because I don't really need that anymore. And we're going to start with our access events, which will be our move forward and our move right. So we need the exact name, so I'm just going to be, again, paranoid and copy and paste everything. So we have move forward, and to get this, we're going to do input component And we're going to do bind access. So it's an access event. If you don't know what I mean when I say access event, we go over here, access mapping, action mapping. This is an access event. So we're going to bind access, and then we're going to use brackets. Now you can use an F name here if you want. I'm just going to hard code the name in of move forward. And we then need to pass in an argument. Well, before we can do that, we're going to pause here real quick and go back to the header. We need to finish setting up that argument. We're going to do it for both the move right and move left. So we're going to do, under our setup component here, 2 new functions. One will be virtual void, and I'm going to name it call move forward. I'm going to pass in a float, what we'll just call value. And then we're going to do another virtual void. That should not be a capital V. That will call, or that I will name call move right. And again, we're going to have a float, and we're naming the float we're passing in value. All right, so let's go back to the class file here. And in the class file, well, what's calling it is self. This is a reference to self. So we're calling a function elsewhere. And if you remember, we call a function up, you have at the top it says target. Well, we need to say what the target is. And self in C++ is really this. So this file, this thing is calling this up. I know I'm doing a poor job explaining that. If you follow my C++ tutorial videos, I will go into more detail on what this is. I know I am glossing over it. And we're going to do this as a pass by reference to the controller. So we're going to do the controller namespace, and it's call move forward. So this is the binding. So when we press our move forward keys, which are W and S, it is going to, from this, find our RTS controller and find the event called call move forward. We need to do the same for move right. So again, input component. Again, it's a bind access event. And to make sure I get the name right, I am going to, because I probably typoed somewhere, I'm just going to pop this back open. It looks like I spelled it right, but still, I'm paranoid. Double quotes. Paste that in. Again, this and comma. We want to point to our player controller again at the address, not point to, sorry. We want to get the address of our player controller, and we're going to do call, or the reference to our player controller, move right. All right. So now that we've said these buttons are calling these functions, we need to actually say what these functions are. Because right now, if we press W and S, nothing's going to happen if this were active. It's just going to go, all right, I have a move forward and I have the move right event that I'm calling, but we have nothing that actually says what move forward or call move forward and call move right do. Now the reason I've named these call move forward and call move right is we already have our basic movement input, and somewhere in here, not movement speed, there we go, basic movement control. We already have a function that does our movement for us. We are just calling this function up in a very kind of, to be honest, roundabout way. Sorry, I'm just saving everything. Why is it saying I have a typo? Sorry, I'm just going to go through this real quick to make sure I'm not missing something. Input component, bind access, move forward, this. Player controller, call move forward, input component. I'm going to be paranoid, and I'm just going to copy and paste that entire line right there. Alright, I'm still getting the same error. I will check if that error goes away once I've actually defined the call move forward. So I'm thinking that's what it might be. If it hasn't gone away by then I will start panicking. Because panic is useful, right? Alright, so the functions we're going to call are make are very simple. We already have them declared. We just need to define them now. So we have void, and again, I'm going to actually be very lazy and copy both of these because I need both those parts. There's the function, and we're passing in a float, and that float we've named value. And this is how simple this function is. We are going to, from here, get the reference to our camera movement component. Sorry for that noise. I forgot to actually mute the computer noise. And thank you for whoever just subscribed on YouTube. It's not popping up on my screen, so I actually can't see who that was. And I'm just going to mute my desktop audio so that doesn't happen the second time. So, this is, again, very simple. All we're doing, we're taking our movement component ref here. I'm going to copy it so I get the name right. And we have our basic movement control. And I'm going to go over to my movement component just to make sure I got that name right. Yeah, it's basic movement control. I'm still going to copy and paste it because paranoid. Okay, it is the same. And we're going to pass in value. And value will be handled by the system. Now, I had to pass in a second value because I didn't make two separate functions for this. I made one function. I went to the wrong thing for that. Is because we have one function that handles both the x and y axis, so both forward and right. So this is forward right here. This is our x value. And the reason I know that's my x value is axis value x, axis value y. Well, if we're pressing the W or the S key, then that's going to either be 1, W, or -1, S, for value. We know then our left and right are 0. So I'm just going to plug in 0.0. All right. Now, this error, as I said, I'm going to need one more header in here, right? This error is because I am missing one of the headers. And the header that I'm missing is the camera movement components header. So I'm just going to cheat a bit and find my camera movement component class file, scroll to the top, and I'm going to grab that header. I'm going to scroll back down so I can reference things in here in a moment. Paste that in, and notice that error goes away. Also, notice now that we define this, the error here has gone away. Thank God, I don't have to panic. Okay, so all we have to do is reverse what we've just done here, and I'm going to be a bit lazy. I'm just going to copy this entire thing, but for the move right. So if we take that move right, paste that there. Again, we're passing in that float of value. Well, remember, it's A and D now, and if we look back over at our movement component here, well, that's X. The second argument we're passing in is Y, so left and right. Now, we need to reverse these. So this value is going to become 0.0, and the original 0.0 from what we copied will become value. So now that we've done this, we now have forward and backwards and right and left programmed into our player controller. All right. Now we have other ones we need to put in. We need to put in our, let me just pop open the file here. We're going to skip the pan. We're going to skip the pan. We're going to skip the zoom for a moment. Our speed modifier is next. And we have to actually do our speed modifier twice. And if we, wish I hadn't closed this actually. If we look at our speed modifier here, we have a pressed and a released. So we have to do one for pressed and one for released. So the way we do that is we're going to go in here, and I'm just going to copy this name. And I'm going to cheat. I'm just going to paste that name there as a comment because that's actually what it is. And I'm going to say increase movement speed while shift is held down. So I remember what I'm doing. Actually, I have a second one. Gotta put the comment lines in, which will be restore default movement speed when shift is not held down. So we'll have two functions we need to do. So let's go to our header file and make those functions. So we have, as you see, our call forward, our call move right. We then need our call increase. Again, I'm going to use the word call because I'm calling other functions up. And this is a reminder to me that these functions aren't actually the function for moving forward, the function for moving right, the function for zooming in, etc., are not actually declared or defined in our controller. They are encapsulated elsewhere. So we're going to do virtual void call increase speed modifier. We're passing in no argument there, and then a virtual void call decrease speed modifier. And again, we're passing in no arguments there. So again, we are getting the error saying these are undefined, or sorry, the definition is not found, so they're undefined. I don't know why I was doubting myself on the word defined there for a second. So what we need to do to fix that is put them in here. Now, this is slightly different than our axis events. These are now key bindings. These are action events. Again, if we pop back over here, action mapping, axis mapping. Oops, sorry. We still do input component, but what changes at this point is we're now doing bind action, and I copied that name and pasted it there, speed modifier, and then we're going to do when it's pressed. So it's IE underscore pressed, comma, again, this, and we're going to cheat a bit. We're going to copy everything including the ampersand, so the address. So we then have call increase speed modifier, and I'm going to cheat and copy that entire line, and I'm going to paste it down here, get rid of the extra space it put in, and then instead of IE pressed, we're going to do IE released. So when we let go of the shift, and this will be call decrease speed modifier. Again, we're getting this error because this is undefined. It's going, well, you haven't actually done anything with this. I don't know what the heck this is now. Also, because I've got the semicolon on both of those. All right. And I'm paranoid I got the name wrong, so I'm just going to copy that real quick and paste that in there. Oh, the D isn't capitalized. Let me fix that. The D should be capitalized. Sorry. I just want to make sure that's right. All right, so now what we're going to do is we're going to take this. I'm just going to copy the increase here, and I am going to do a void again, because that's the type we declared it as. And then now we're passing this function in. We have no arguments to pass in. So again, this is fairly simple. All we're doing is calling something we made in the last video. So if we go to the last video, or not last video, if we go to our movement component, I'm going to close this out. So there's our basic movement. We have zoom in, reset, setters. We have our set movement speed modifier. It's actually why I just closed. So we have this set movement speed modifier that we created. All it does is it returns a float, and that becomes our modifier amount. And then if we go here, we have our default movement speed is equal to the movement speed adjustment. So we have the functions in here that we're calling. Everything has been set up for us. So all we're doing is just calling that up. So we're going to use our camera component ref again, and we are going to point to that function in there. We're going to say, I want you to do what's there. And all we're going to do is, I'm going to make sure I'm using the right one. Sorry, give me a second. I am just double checking my notes. So if we go back to our camera component, pretty sure it is set the movement modifier there. It is. So we're going to take our set movement modifier, which do notice it has an argument. It has this modifier amount. Even though we aren't passing an argument in here, we're going to pass an argument at this point. So when this button is pressed, what we are doing is we're setting this value to 2. Now, let me just pop open this file for a second. Let's go back here. Notice there's no value. There's nothing we're passing in. There's a key we have here, but there's no actual float value. The float value is this here. So it's our set movement modifier. Modifier amount. Set movement modifier. Hang on. Set movement speed modifier. I just saw different names for a second. Set movement speed modifier. And again, modifier amount. And that 2 is our modifier amount. Oh, I forgot the A at the start of that. There we go. Now we need to do the reverse for this, which is our decrease. I'm going to cheat and just copy that again. And all we're going to do here is we are going to set that value to 1. We have nothing else to change in here. And we're going to change that to call decrease speed modifier. So again, fairly simple. If we pop back over to our blueprint version, there is what we've done. So we're saying, instead of calling the camera ref and then getting our movement component, we already have a reference to our movement component filled in, so it's a little bit different than our rig and play here. We are then getting from this movement component, when this event happens, on pressed, our set speed modifier, we're passing an argument of 2. When we release the key, we're getting the same function, which is again set movement speed modifier, and passing in an argument of 1. That's literally all we're doing here. We've done all the hard work elsewhere. And again, I need to stress that these functions have to be in here. I cannot directly, I can't do, let me just show you something I can't do real quick. Sorry, I'm just going to put that down there. I can't do, these are in the camera movement. So I can't do this. And I'm just going to show you what I wish we could do, which is that. And then that was the increase one. Yeah, pressed. I cannot do this. This will not work. It's going to give me an error here saying non-static member reference must be relative to a specific object. That is just say, oh, also I skipped another thing there. There should be 2. So that error there is saying I can't actually reference this here. So the functions that I call have in my input event, so in my setup input components, have to exist in the function, or in the class, sorry. Let me try that sentence again. Again, I enjoy being able to edit videos. When I use an input component, I have to call functions that exist in the class in which I am using that input component. So if we went to our camera pawn and put, because in the pawns you can use the setup input component, I could just call these up there, but again, because they're coming from the movement component ref, I would still have to create functions in the camera pawn itself that calls the movement, that calls it from the movement component. So you're going to end up having a little bit of a chain, but again, it's good encapsulation, it's good practice of OOP procedures, and it's good to keep the things, well, encapsulated. So we've taken care of our basic movement. We have move forward, backwards, left, right. We have speed up the camera, slow down the camera. All right, now that we've done the basics, I'm just going to minimize these functions. And we're going to move on to the next set of functions, which will be our pan the camera left and pan it right. Now, I'm going to start in this video. In a later video, we will come back and refactor this. I am going to start with a very simple panning procedure of, let's do 45 degrees. I mean, you can pick any number you want. You could pick 1. It would just be a very tiring process of pressing the button over and over and over again to get the result you wanted. So we're going to do 1 for call pan left, pan right, and reset. So if we go back to our header file here, we're going to do a virtual void call pan camera left, passing in no arguments, to this function. The function it calls, we're going to pass in how much we want to pan the camera by. And then we're going to do the same for virtual void. Did I actually set up a left and right? Sorry, I'm going to double check my project settings. Pan camera left, pan camera right. I did. Okay. Call pan camera right. And then virtual void call pan reset. I just had a really weird moment where I thought the S was capital and not the R, and I was confused. Also, I have definitely spelled virtual wrong. Alright, so now we have 3 undefined functions, and we need to make their input events as well. So, we're going to do this one a bit backwards, just because I'm getting sick of the red lines up there. We're going to define the 3 functions first. So I'm going to just cheat. I'm going to copy all of this. I'm going to paste it in there, and get rid of the virtuals. And again, I'm going to cheat and copy that part. Paste that in. Paste that in. Paste that in. And let's get rid of the red real quick. Okay. There we go. So now let's fill these in. Let's do our pan left. And for our pan left, and I hope I'm going to do this one right. Sometimes we'll get the negatives and positives backwards on this, so if I get it wrong, I'm sorry. Pop that open real quick. Just grab the movement component. We're going to call a movement component. We have a function in here for panning. So it's the same function we're going to use in both the pan right and pan left. If we go to our movement component, let's see. We're set disable. There's our pan camera. So all we have to do is pass in a float amount that's our rotation. And it's going to add it on the proper axis, which this is our Z axis. Don't ask me why these aren't in the right order. So if you're not sure what the order for it is, I know I put it somewhere, and here's a note to myself, because I always forget. They aren't in the order which you'd expect them to be. Clearly, I didn't put the note in here like I thought I did. Give me a second. Let me actually get the correct order they go in, because it isn't rational. I don't think it's rational. Probably put it, you know where I probably put it, actually? Is I probably put it in the camera itself. Knowing, there it is. It's pitch, yaw, roll. So it's Y, Z, X instead of X, Y, Z. It just well, welcome to UE4. Welcome to UE4's API and C++. Okay, sorry, I'm gonna stop that now. So let's go back down here. So all we're doing is we are passing in. We have a function called pan camera. All it needs is a rotation amount. So we're gonna actually just be lazy and copy that, and it sets that rotation amount there as new rotation, or it sets new rotation, gets a camera rotation, adds the amount we're passing in, and sets that to our new rotation using the set actor rotation. So if we go here, we can paste that in. I skipped the P on that. Jesus, really? All right. So the amount we want to pass in, you can put any number you want in here. Seriously, you can. You can put 1 in here. You can put 1.0 F and walk away. You can do 45. You can do 90. You can do 15. I do recommend things divisible by 90 or divisible by 90, divisible by 15. So 15, 30, 45, etc., 90. Basically, you want to be able to do, 15 will guarantee you're going to get back to the same starting spot. The number has to be evenly go into 180, or 360, sorry. It has to evenly go into 360. So I'm going to start with 45. So this will pan the camera 45 degrees to the left. Now, I'm going to take the same exact code here, and I'm going to paste it there. The only difference now is I'm going to set that to a negative. So the positive and negative determines if it pans left or pans right. Now, if you're doing this from scratch at home, sorry, that sounds really stupid, you really should be testing each step along the way. Now, because of compile times and because I'm live streaming, I'm not testing along the way. I'll do one massive debug at the end. But you would want to test when you did the move forward and we did the move right, especially because these are a unique way of doing it where you're passing in argument, we're using the same function instead of having two separate functions. I would then have done a test after I've done the increase and decrease, and then once I finish these three, I would run another test. But again, because of compile times, live streaming, and all that fun jazz, we're skipping that step. We'll do one massive debug at the end, as I just said. Now, our reset pan, well, we have reset pan right there. Let's take a look at it. Well, we don't have to pass anything in here. It just sets it back to 0, 0, 0. If you have a default rotation, which I think I didn't have in this one, because we're just assuming the camera is going to start facing at this setup, then you'd pass that as the F rotator in. So you'd have an F rotator declared up here, or defined up here. You would declare it in your header, and then you'd pass it through in here. So I'm just going to copy the pan reset, and I went one file too short. And we're just going to pass in the pan reset. We have no arguments we need to pass in. That is how simple that function is. Well, now we've declared the functions, we actually need to, you know, give them input events here. So, because this is movement related, I'm gonna have this all as one pair, like one block. Movement related to basic movement. And what's related to basic movement? Input events related to basic movement. And then we're gonna have input events related to not basic movement, to other movement. All right, so we're gonna do first our pan camera left. So that's the first one we have up there. We're gonna do input. Actually, sorry. Before we go forward, I want to double check that I have the correct name from in here. It is. I spelled camera wrong. See, this is why we do this. Had I typed in pan camera left here properly and not caught that typo, it wouldn't have worked. So input component bind action pan camera left. I've copied and pasted it after I fixed the typo. Again, had I not gone back here and not seen that typo and had properly typed it in here, it wouldn't have worked because there is nothing with that name. All right, we're gonna do this when the button is pressed. And it's this at address of the camera controller. And the function is our call pan camera left. We have nothing to pass into there. Of course, we can't pass any arguments into here. Another thing is when you're doing these, you can't pass arguments in here. Arguments have to be passed in elsewhere. So arguments cannot be passed in inside the input component. All right, then we have our pan. Sorry, the lack of space is gonna drive me crazy. Pan camera right. Again, even though I just double checked it when I was doing this earlier, because of that typo, I'm just gonna cheat and paste that in there so I have it ready to go. Copy this bit, copy that bit, paste that over there so we now pan camera right. I don't know why that looked wrong to me for a moment. And then we can just change this to call pan camera right. And we see it's calling the right one up. And then finally, on this one, we have our reset pan. And again, we're going to go back in here. We're going to make sure the name is right. That's reset zoom, reset pan. Just paste that into there. Oh, it's pan reset. Did I have it the way I did? Again, this is why we check what we are doing. Input component, bind action, pan reset, i.e. pressed, this, and again at the address of the movement, or sorry, the player controller, and it is called, is it reset pan? Or pan reset? Pan reset, okay. So now we have our pan reset. Next we have our zoom in, zoom out, and reset our zoom or default zoom. Did I actually name it? Is the question. Reset zoom. Okay. So let's declare the functions for that now. Let's go back to our header file here and Control S save everything. In our header file, well, we just have 3 more functions to create. We're gonna have a virtual void call zoom in, no arguments being passed in, virtual, sorry, hang on. Sorry about that. Pascal casing all the way, yo. Virtual void call zoom out. And then finally another virtual void of call zoom reset. All right. Like before, we're going to do the definitions of these declarations for these functions. Ooh, the heck did I just do? I think I just pasted the part I copied over itself. Paste those in, delete our virtuals. Virtuals, take that bit, paste that in, get rid of that, paste that into there. Get rid of the semicolon, put our curly brackets in. I forgot to put in 2 semicolons. There we go. And do the same down here. Make sure to put both semicolons in this time. And now we have our 3 functions. There's nothing really in them. What do you mean not found? They're right there. There we go. Sorry, I actually wasn't angry. I was trying to be funny sounding. I came across sounding very angry, I realized. Alright. So, let's take a look at our zoom in, zoom out, and call reset, or call zoom, or zoom reset inside of our movement component. Let's close that out. Let's close that out. And remember, they're going to do something on the tick. That's the edge scroll. So here's our zoom in. We have this entire setup for our zoom in. Sorry, I swear I did more with this in the last video. Oh, it's the rotation. That's the part I was worried about. I swear Sorry, let me check my notes on something real quick. Because I swear we did more on this. I remember talking about having to create a custom clamp. I might not actually have done it. I might have just talked about having done that. And that's what I'm remembering. In my prep file, I definitely did do it that way. You know what? Well, we'll be able to test in a minute if I'm going crazy or not, because we'll get some weird effects if I didn't do the thing I thought I did. So, if we go back here and look at what we have to pass in, we're passing in nothing. It automatically sets the zoom because we have variables that change how much we zoom in. So, our default length, how much the arm changes by when we zoom in or out. That's why we have this times -1. We take our delta arm, which is 150, we make it a negative number, so -150, meaning the camera arm, the spring arm, gets shorter, moving the camera closer. Now, again, this technically isn't zoom. Zoom is about the field of view. So if you wanted a proper zoom, you would actually update your field of view. I'm having a nightmare setting up this angled mouse cursor. Oh, have fun with that. So I was just reading a comment in the chat. So, from one of my mods, by the way. That's why I'm giving him a hard time by saying have fun with that. So what we're going to do with this call zoom in is literally call the zoom in function right here. So that lovely zoom in function, all we do, paste that in there. Again, let's pop open one of the earlier ones. Grab all of that bit. Boom. Oh, also put the semicolon in. That's all we're doing. Again, all the heavy lifting for this has been done in the last video. Fun part is we can copy all of this and change that word in to out. And the reason we can do that, so you go back here, we have our zoom out. I swear, because of this rotation thing. So again, we're changing the rotation. As the camera comes in, or as we zoom in, the camera is gonna move to be from more of a perpendicular angle to more of a parallel angle. It's still not going to be parallel, but closer to parallel as we zoom in. So this needs to be negative to move the spring arm closer or make the spring arm shorter. This is positive to bring the camera closer to the ground. And we reverse this when we zoom out. We don't make this a negative number. We increase it by 150 so the arm gets longer. And we change the delta rotation to negative, which brings the camera from being closer to the plane that the player is on, or the ground, to the terrain, to being at a steeper angle and closer to being perpendicular. It actually never gets truly perpendicular. So we have our zoom out. Why are you saying that function doesn't exist? Oh, because there's a typo in this function. Cool. We're going to fix that typo. I forgot to make the O in zoom out uppercase. Cool. All right. It exists now. Don't tell me it doesn't exist. Thank you. And thank you. As for our zoom reset, if we just close these out, well, all it is default zoom. Set to default zoom. Let's find this in our camera owner, which is our camera pawn. So if we go to our camera pawn RTS, we look for set default zoom. So we have set arm length, which we called up the other one. Oh! I did make a clamp. There's the clamp I was talking about. Okay, so, yay for that. So there's our set to default zoom, which we just get our default zoom length, which is defined somewhere up here, I think. I don't remember where I put it. You know what? We're gonna cheat. There it is, the default zoom length. And then our default rotation, our camera rotation, which is just directly above that, is right there. So this one, again, was due to just numerous issues of encapsulation and making sure we were able to call everything we need to call. But it just goes into the camera owner. So we're actually going to go from the player controller to the camera pawn to the camera component or movement component to the camera pawn again to call this function up, technically. But hey, you know what? It works. And the reason why I say we go from the player controller to the camera pawn is we have to get the camera pawn. From the camera pawn, we get the movement component. From there, we come back to the player controller. We go back to the movement component to call this up. This event that we call up then calls up the camera pawn itself and resets everything. All right. So now that we have the functions, again, we need to do the input bindings for these functions. So for that to work, we're going to have our zoom in. And in fact, actually, you know what? Because of the typo earlier, I'm just going to actually copy reset zoom because everything else is the same. Zoom in, zoom out, capital to the right. Okay. I'm not so paranoid anymore. Zoom out. Just watch the zooms not work because I didn't see the capitals were different or wrong. Put our spaces in. And again, it's going to be input component bind action. And this is zoom in. It is when we have pressed the button. Again, this at the address of our camera controller. And we're calling our zoom in, call zoom in. I put way too many semicolons there. Oops. All right. We can copy all of this. I have the lurking suspicion zoom out's not going to work because I changed that typo. Do that. And then we can do it one more. Oh, sorry. Hang on. I lied. We can't do it one more time yet. Zoom out. All right. Copy this. Yeah, I'm getting paranoid. And the word zoom after a bit begins to look like it's wrong. Like it should be spelled differently. All right. So that's all of our main input events. Now I mentioned we're going to do something on the tick. And that's the edge scroll. Now, again, we're probably going to refactor this later on and create a timer for it, or create some other way to call it up, maybe using a gate like we did in the blueprint version of this. But for now, we will be doing this using a tick, just because it will make life slightly easier. All right, so to do that, let's go up to our tick. And this is really easy. We don't need to create any special functions to do this. All we're doing is, when I say special functions, we don't have to do all this rigmarole here that we did. All we need to do is to get our camera movement component ref. And let's go over to our camera movement component for a moment. And somewhere in here I have edge scroll. There we go, edge scroll. So here's our lovely edge scroll code from the last video. What we need to do is get our edge scroll, the function name there, and just call it on tick. So we're using our pointer to get to that particular function. All right. I'm a bit paranoid. I'm still getting that error message, actually. So we have our header for this thing. We have our player controller header. We have our input component. We have our movement component. We shouldn't be getting that error. I'm just going to go in here for a moment. And, you know, sometimes these errors aren't actually real. We have our core minimal. We have our camera pawn. We have our player controller framework. Don't need that, don't need that. And then we have our generator. So the ones I don't need, I was just saying don't need, were a reference to stuff for the UI, which I don't think we'll be doing this way, at least. So next what we need to do is we actually need to call this player controller up in our game state. Or sorry, not our game state. I don't know why I said that. In our game mode. And because we get a built-in game mode, actually technically we don't need to call up in our game mode. We could just take our test game mode here. Well, first what we're going to do is we're going to hit compile. And we're going to sit here for a moment while it compiles. While it does that, I'm actually going to pop open the game mode we get as the base. Really, it should just automatically open. There's our game mode. There's the header for this, though. There's our header. And you just hear that, oh, you can't hear but turn the sound off. It's compiled. We can actually do a quick test using our test game mode here. And all we need to do is set our default pawn. That's set to a camera pawn. That's good. And we take our player controller here and we set this to our RTS player controller. Compile, save this. Probably do the game mode in a later video. Come back here. Make sure that that's our RTS camera pawn. Hit play. We didn't crash. That's a good starting sign, right? All right. Mouse cursor showing up. It's another good starting sign. Oops, sorry, I didn't mean to edge scroll. Well, we know the tick is working and the edge scroll are working. Boom, boom, W, S, D, A. And now I've forgotten the actual other one, so I'm just going to take this and pop it into another window so I can see it. I'm definitely edge scrolling somewhere where I want to be, so I'm going to restart it. All right, there's our zoom. You can see the camera gets closer to the ground as we zoom in and out. Sorry. All right, and let's just zoom out and hit R. There we go. Zoom in and hit R. And what are my rotations? It's the right arrow or full stop for right. There we are. We are rotating 45 degrees right. Let's go 90 degrees right. Let's go back to the left. So left is working because I used to use the left one to do that. Let's go, 90 degrees left. Let's go to a weird angle, and then we use the slash key or the question mark to reset. And our reset's working. As I've already shown, our edge scrolls are working as well. So, we have a functional player controller now as well. And to evidence that this isn't running really on this, we're going to actually, ooh, I should have done it that way. We're going to do is we're going to hit stop here. I'm going to, why am I getting errored on this? Further evidence this isn't change is that error, and I know exactly what that error is. It's that zoom out. It's not going to work, but. Oh, I also, pan camera left no longer exists. Also further proof. If we hit play and we switch this over, you see there's no object there? So this is running on the C++ code. And that takes us through setting up our player controller. Probably in the next video, what I want to cover with you guys is setting up boundaries and starting our game clock. I will likely for a long time just use this game mode because it's easier to set things up for testing than having to compile and find the right class files in the C++ version. But now that that's said, we can say bye-bye to that thing. Bye-bye. Really? Okay. And again, further proof. Oh, sorry. Left, right, up, down. So, we'll do our game clock. We will do our boundaries in the next video as well. So I think that this actually takes us outside of boundaries through everything we did in section 1. Now I realize it's 4 hours of videos technically. There's an hour and about 15 right now I think on this one and 3 on the last. Well, the 3 on the last, it's really 2 hours because I spent an hour answering questions afterwards. No crashing is always good. Thank you, Chica, for that. Thank you for the agreement that not crashing is good. Not crashing is always a good sign, ladies and gentlemen. But, you know, in 3 hours... Sorry, my mic filter does not seem to be working. In 3 hours, we've done everything we did in the first, I think, is it 8 lessons of the original series? I'm just going to pop open the thing now and see how many lessons there were in that first section. And we also did it without me being a jerk and going, here's a semi-functional code, we're gonna fix it, and then me giving a completely unrelated solution. Yeah, that was intentional, by the way. That wasn't accidental, that was intentional. So, wow. We did the first 7 videos, first 6 really. So, one of those is an hour. Jesus. Actually, to be fair, in the amount of time we've done the C++ is the same amount of time. Actually, it's a little bit shorter than those 7 videos, or the 6 videos. So, you know, it's 2 long videos, I realize, and I'll eventually go back and put timestamps into the first one and at some point to this one. But the C++ is relatively simple. In fact, actually, what we're doing here, minus some of the things with the pan and with the use of the tick, are better practice than what I did in the first 6 videos of the Blueprint version. And also slightly less jerkish for my jokes about, not joke, my method of teaching, where I put a challenge for it. I should have realized in YouTube you can't use that method. It doesn't work. I thought it would. If we place our pawns inside of blocking volumes for boundaries. Yeah, that's actually what we're doing. Is we're going to use blocking volumes, but we're going to set up a custom collision profile. So in fact, actually what I'm going to do for the boundaries in the C++ version is slightly better than what I did for the boundaries in the Blueprint version. Because the Blueprint version, you have to go in and manually set them. Here, we manually set it once, and then we can call that setting up wherever we need. Oh no, it'll still work. You just have to make sure you set the collisions correctly. So that you have 2 options on how you do that. So option 1 is you go in and set the collision to catch the pawn every time. You just set it up to block that, and a pawn to be blocked by the wall. Or you create a custom collision profile that allows you to just have something that automatically you call this profile and say, the blocking volumes work for you kind of thing. But the reason why we use a custom profile is we want the pawn. So you can't. I'm not playing. Sorry. There we go. I'm not playing. There's actually a sphere here. We just can't see the sphere. That sphere, at some point, I'm gonna pass it through that block, or let's actually extend that block out. So we have a nice long block here, and I know the sphere is directly against that plane. By the way, I'm able to pass through there without any issue because it ignores collision. The spring arm doesn't respond to it. But if we have the pawn not properly set up, it can actually cause issues if you're not being careful. The blocking volumes will work, but the pawn might respond to other things as well, which is why I use custom collision profiles. So it is a workable option, and again, we do use blocking volumes. It's just about setting the correct profile for those. If you don't know our profiles, let me just quickly show you in here. So we have our object channel, the trace channel, and then we have this thing called presets down here. If we pop this open, here are the presets. So like whenever you go in here or into an actual mesh or class file or blueprint file, and you scroll down to, I went right past it, collision, and you have this bit here, this yes, default, custom, etc. Let's put it back to default. Actually, no, hang on. Let's look at this list for a second. This is the list of profiles minus custom. And default is whatever you set in the parent class. So, sorry for the background noise. The default for this is block all. Is that actually going to cause issues for my camera? No, okay, it isn't. Just making sure my camera's going through this. If I zoom in, I know it's going to go through it. So, it's a profile we can set up in here that the blocking volumes will use to work with our camera. So if you want to get ahead a bit, you can look at the video 7 from the original Blueprint series, take the settings I use in the blocking volumes, create a custom profile here, and then in your C++ code, call that collision profile up. Now, it's literally about 5 minutes worth of work, and I'm including compile time in that. So it's a relatively simple thing. That's why we're going to be doing that and the game time. So we'll be doing video 7 from the original series and video 8. It's the first video of section 2 in one video. And I will say, for everyone who questioned me on not using the date-time structure in the Blueprint series, there's a reason I did that, and that was, again, purely for teaching the logic. In the C++ version, I will be using the date-time structure. And I know I'll be using, so I've already written the code, by the way, but because it was just so much easier to use in C++ for what I wanted to do. What we will not be doing, and Chaika can attest to this, so my moderator who's in the chat can attest to the issues we had with this, is we will not be using some of the built-in functions for setting up our calendar in the UI, because those functions do not operate properly and are just, I think it took me 2 days of working on it before I quit, and I think Chaika spent, I'm not sure how long he looked at it for, but everything according to the API we were doing should have worked. It didn't work. It was, and it also technically it isn't production ready. So what we're going to do is actually recreate something that's in that particular class file or that particular class, and we're going to make it production ready and one that works. I'm sure somebody in the comment section in that video will go, hey, by the way, this is how you make that particular function you're struggling with work. Just remember, there's a lot of... by the way, before I actually go on, first, thank you for the compliment there. Thank you for, watching the videos, first off, and thank you for telling me they're amazing. I know the earlier ones weren't the best, and that was because I was learning how to YouTube, so to speak. And I was learning sound editing, video editing, learning that the recording software I was using was not adequate. So I apologize for the earlier videos. But I'm going to call myself out here a bit. And I said this in those videos. I say them in a lot of the Blueprint videos. What I'm making in the Blueprint version is not meant to be production ready. It's meant to teach the logic, the procedures, the understanding and the familiarity of using blueprints in Unreal. I picked an advanced topic for that because it is one that actually is achievable. It's a little bit daunting, but when you accomplish it, you have this feeling of success, which is wonderful. But because it's this more complex thing, you're learning more about it. We're covering things from classes, inheritance, event dispatchers, which I kind of forgot about like halfway into the series. Whoops. I know I use event dispatchers early on, but I forgot about them after a bit. We didn't use data tables, much to probably Chica's chagrin. But we're using behavior trees. We're using a whole bunch. Oh, we're using random spawners too. We're creating spawners. We're using blocking volumes. We're using a whole bunch of different things just to get familiar with how they work. The C++ version of the series is going to be much more about proper object orientation. So as I'm doing this, that's why I keep talking about the fact that we have encapsulated everything in terms of movement in the movement component. Anything related to the camera and the movement component actually calls up the camera to do it itself, which is like the zoom stuff is all really run in here, the math for the settings. So the camera is aware of itself. My neighbor's dog is driving me crazy. I'm so sorry for it barking. My dog's asleep for some reason with a random box. But so like our pawn here, it knows about its sphere, its camera arm, its the camera itself. The movement component knows about movement, and then anything that changes the variables for like the zoom out, the default zoom, the rotation of the pawn, it actually calls up the functions. It actually calls up functions inside the camera, so we have proper encapsulation. So this series is going to be a bit more properly, a bit more proper in OOP procedures. Oh, I am so used to being able to take breaths while doing these things, and being able to edit videos. I have, by the way, just for people aware, for the BP series, the Blueprint series, there are other videos recorded. I just have not had a chance to edit them yet due to my work schedule. In fact, I have something like, I think 40 plus videos unedited for different series on YouTube. I have the next series after the tutorial for the RTS series is done. I have 4 in the RTS series or 5 in the RTS series unedited, and I think I had the next C++ one, which was supposed to be released like a month ago. And when I say it was supposed to be released, I mean as part of a set of videos, all recorded, just unedited. I apologize for the delay in getting those out. But again, I just want to point out, in 3 hours, we have done everything I set out in the first 6 videos of the Blueprint version. By the way, if you're getting this error, don't worry about it unless it won't compile, and then start worrying about it. This is a very standard error to see. And you might get some other ones, like when you do structures, or you do... I now can't remember if UE nums. So the Unreal version of enums, I almost said Unity versions of enums. The Unreal version of enums actually uses the generated body. I know the U-structs do. So if you see this, don't worry about the error. It happens. Yeah, so if you change the viewport size, you'll still be good with the movement. Because what we're doing with viewport size, both in the Blueprint version and in the C++ version, let me just get it up here because it's in our movement component. And there's our edge scroll. It's the last thing I did. So if we take a look at this, I know this is very confusing for a moment. This is the part we care about, really, right here. That highlighted section, this get viewport size, and we're actually storing it here and here. All we're doing, and this is the reason why I don't want to run an ad tick, why we're going to come back and refactor it later, is it's going, what is the size of the viewport? And the viewport is that play screen. So, not the entire monitor. What's the size of the play area? And then we get the mouse position in the world. So we're getting the mouse position. This gets it within the world, so within the viewport, and it goes, what proportion are we covering? So because we're getting the viewport size, you can resize it and it will still work just as fine. Now, what you might want to change, if you change anything, and this doesn't relate to viewport size, this is just about preference, are these numbers. So you notice that 9.75, that 0.205. I'm going to stop saying point. These are really proportions, so I'm going to just use not whole numbers. I'm going to use percentages. So this is 97.5%. This is 2.5%. This is, again, 97.5, 97.5. So when we have proportion X, that's our left and right. So top right, so 97% of the screen is covered. You can't see my mouse as I do this. I don't have the nice drawing of this up. So what we're saying with proportion X is, if we're on the left-hand side of the screen, that's 0 proportion when the mouse is right against the left-hand side. As we move to the middle of the screen, we're at 0.5. And when we move to the far right side of the screen on proportion X, that's 1. Remember, X and Y are reversed for the screen than they are in the world space. So X is across. So at 1, we're at this side. So when we say 975. So 97.5%. We're saying the mouse has covered 97.5% of the screen to the right, and this Y has covered 2.5% from the top. So going from the top is 0, the bottom of the screen's 1. You saw my toolbar popped up when I went to the bottom. So 2.5% is pretty much the very top of the screen. And so if we have both of those, that's the top right corner. That's why I picked that as a good example. It has both. Again, 2.5 is a very small amount. You might want to make that, 5%. And then if you do this as 5%, you need to change the corresponding proportion Y here to 0.95. So this becomes 0.05. This becomes 0.95. But that's just all about preference. Changing the viewport size, again, will not affect how this works. You might, again, just want to consider changing the proportions you want to cover. I just chose these numbers because they make me happy as a statistician. I can't use 0.005, though. But as a statistician, it just made me think of two-tailed versus one-tailed tests. So that's why I did that number. Sorry for the ramble there at the end about answering that question. And also, sorry for my squeaky chair. I need to get 2 new chairs. Oh. I also need to get a new spinal cord because this chair is killing my spine. The lockdown here in the UK. Yeah, I know I have an American accent, but again, I live in the UK. The lockdown has been murder on my spine just because I have to sit in front of my computer all day. It just is not a pleasant experience for that part. That said, I am lucky to be in work and everything, but I'm going to complain about my back. Understood. Thanks again. But my first implementation, like if mouse position X is greater or equal to mouse position X is equal to or greater than player controller, get viewport size X, viewport margin. I mean, you could. I'm assuming you set minus viewport margin. Sorry, I misread that. I'm assuming you've set a viewport margin. You could do it that way too. I just like the proportion amount because it gives me a little bit more flexibility when you have the top right, top left, and bottom right calculations to worry about. But here's the thing: if the code works and it follows the principles of encapsulation, abstraction, inheritance, and I can't remember the fourth one. Someone's going to comment about me not remembering the fourth one. So long as it follows the basic OOP procedures and it works and it isn't a memory hog, then it's good. I often tell people when they watch my videos or any tutorials on YouTube, on Udemy, on Pluralsight, anywhere where you can find a tutorial. If you don't know what you're doing, yes, follow along and then try to work out what they're doing and then experiment. If you do know what you're doing or you feel confident enough that you can play with it or try a different approach, try something different. See what happens. It's one of the best ways to learn this material. I said it was an hour 30. It's now an hour 35. I had to have stopped the actual coding about 30 minutes ago. Polymorphism. Yeah, and I was ranting about polymorphism last night on the Discord channel. I forgot to do something really important, speaking of Discord. I've got to say that this series has been brought to you by support from my community. It's been brought to you by support from, people like Chaika, who act as my moderator and community manager at times. The at times is for the community manager. He's always acting as a moderator. He even tries to moderate me. I'm bad at listening, though. He's a good person for trying, though. I'm just a horrible, horrible person to try to control. And also to my Patreon sponsors like Nemian Games and Tristan for all their support and helping fund these sort of projects and these sort of series. And just to my community in general for showing love and support and getting this series out and being understanding when I've been delayed. I said I wouldn't be delayed ever, and then had to change jobs, moved, lost a drive, and now we're back in marking season, so things are a bit slow. I apologize. Again, the videos are recorded at least. I just don't have time to edit them. But yeah, I just want to give a quick shout out to my community for all their love and support. If it works, don't touch it. Sometimes that's true, sometimes that isn't. There are some videos where I have watched them, and I'm just have sat there going, no, I will never do that, just because that is such a bad approach, because it violates one of the 4 principles. And actually, in some cases, it doesn't even violate one of the 4 principles. It's just bad. Like, putting... So, when people say don't use tick, it's because a lot of people don't use tick correctly. And actually, using tick is fine. In fact, the way I use tick is technically what you're supposed to do when you use tick. I just don't like doing it because of the amount of math that goes into it. In fact, though, a timer is on a tick. Anything that's going to be constantly going off, that constantly needs to be checked, that isn't a once off or isn't something where you have a condition, I'm constantly wanting to know where my mouse is going to use a tick. In fact, the blueprint version of it, which uses mouse position X and mouse position Y, those are input variables or input functions, input events run on a tick. So it technically is a tick regardless. We have this connotation that using tick is bad. In fact, the thing is, there are a lot of tutorials out there that improperly use tick. And sometimes, the Epic does it, for example. And they do it intentionally, though, because we're just showing you how something works. They're not saying implement it this way. We're showing you how this function works. We're showing you how this method works. We're showing you how this feature works. You're actually meant to implement it properly when you do it, but a lot of tutorials don't get that, which has led to that backlash against tick, which has led to tutorials saying tick is bad. No, tick isn't bad. It's the proper and judicious use of tick that is important. And also, to help Chica out a bit here, a squared plus b squared equals c squared. The interior angles of a triangle have to equal 180. I should have screwed with him and said something like 175, just to screw with him a tiny bit. Sorry, I've been quiet because I'm checking over on chat just to make sure I'm not missing anything as I rant and give Chica a hard time. I'm sure he's happy I'm getting his name right. And right now, he's looking at his computer, giving it the finger. So, I hope I've at least shown you guys some ways to approach tackling the RTS series in C++. I hope I've answered your questions that you've asked. And I know, again, a few people said they couldn't make it. They posted in the chat earlier. I know what to do, just not to... I will give you a call after this and we'll work it out. By call, I mean I'll contact you on Discord. Just because I need to take a break. My throat is killing me because I've been in meetings all day anyway. And we ended at 1:15. It's not 1:40 on this thing. I say 1:15, I mean an hour, 15 minutes. But I want to thank you all for being here. I want to thank, again, my community for support, people for being here, people for chatting. I like people actually chatting while I do this. And I want to, hopefully hopefully I've answered your questions appropriately and clearly enough to be somewhat of use. Again, I realize that I'm not editing this, so it isn't as clear or crisp as it usually would be, and for some reason my gate filter wasn't working properly at the start, and there's background noise and all that jazz. So I want to thank you for sticking through and dealing with all those issues. That said, I look forward to seeing you either in my Blueprint series, my other C++ series, or in the next live stream. I want to give thanks to, again, my community for their support, my Patreon sponsors like Tristan and Nemian Games. And if you want to be here either for the next live stream or for one of the other series, make sure to hit that subscribe and notify icon. Again, you need to hit that notify icon so you actually get the notifications. You can't just subscribe anymore. It's been that way for about a couple of years, but it bears repeating. And if you want to help this channel out, either, hit that like button, because YouTube runs on likes, just like Dunkin' Donuts, or just like America runs on Dunkin'. Yeah, I had to make that Dunkin' Donuts joke. It's been in my head for a while doing these. Or, consider becoming a Patreon sponsor. That said, I look forward to seeing you in the next video, and I hope that you have a wonderful day.